Hello, everybody. Day two of week 5. We're past the halfway point. I did submit midterm grades the other day. Midterm grades don't really count for anything if you're doing, maybe if you're doing really bad in like all of your classes, the academic advisor might reach out to you, but just formality. When I remembered it was due, I just opened up the grade book and reported what it was that day. Uh, I know some people ask for extra time on some work and stuff, so the grade book probably showed a 0 for that. So some of that might have been low, but those zeros get replaced whenever you get the stuff to me. Today, we're going to look at a little bit of. Oh, in the room. So shaders are when we code our materials. Actually, we'll open up a text file. Might look at a visual editor as well. Visual scripting is the standard for shaders across almost all of our game engines and other graphical software. So we looked at that a little bit of that the other day. Usually, if we're doing, we say materials when it's not binary. So when we say shaders, we're usually talking about the ones that change. So I have a couple little examples that I like to start with. One of them is going to be generative clouds in the sky. We'll just use some noise and we'll talk about what noise is at that point. The difference between noise and just random and randomness. And then also ripples on, thank you. Also ripples on surface of water. So some of the stuff for today, we'll just look at some plugins that make it easier to get a quick start to a game. Or at least get a character moving around the world. We can do that really quick. There's a tour group from a high school. Somebody just closed the door because they knew they were going to get loud right outside the door. But oftentimes for a tour group for a high school, I'll throw something together like that, and in like 10 minutes have a 3D character walking around the world with clouds rolling by in the sky and stuff, and it looks really, really fancy. But then we get into the design aspects of the game, right? Well, why is that character walking around the world? What is the point of that? So a quick start makes it easy. It's good for demos and stuff, but then we get into the more interesting parts of game development. But tools have come a long way. AI is still progressing. I check it regularly. There's a few issues with AI art. For like game assets, one of the problems is we've seen all those super fancy images that AI generated, but it doesn't really know what those images are, and it can't do them without the background. So we can't get still trouble with the transparent images, and AI is still working on 3-dimensional stuff. There's been a little bit of progress there, but it's still lacking. But there are a lot of tools available that can help us with this. So let's jump over to Blender.
And then also a lot of them are trained on store.
Yes. Yeah, that's the whole ethical issue of AI, so that's not different, but it's not quite there for our game assets yet, but there are a lot of generative things. We're going to look at the landscape and trees, and then we'll take like one tree, maybe 2 trees, and create a whole bunch of instances of that one tree so that we're not bogging down memory, but it looks like we have a whole forest covering our area. Oops. So we need to turn a couple plugins on. You come up to the edit menu, and under preferences is where our plugins are. We looked at this the other day. If we go to get extensions, you can search for like landscape. Turned that one on the other day. If you start searching at ANP landscape, whenever the search results pull up, you'll just hit install that one, and then sapling. So like a sapling tree generator. Installed these the other day on my computer here, but you go ahead and install those, that gets trees. For those who haven't had me in class before, I've been working on the next Blender plugin I'm working on is like generates a human shape. It's like fully rigged, no details, just the proportions for a starting point. So you're gonna have to start with a cube. I'll share that with you all at some point. It's still a script at this point, so you just put it in the open it in the scripting tab and run it, and it generates a human that's fully rigged, ready for a skeletal animation, ready for the details to be added. But I haven't finished up a couple of the background steps of making that a plugin, so to actually send to Blender. So once those plugins are on, and there's a lot more. So one of them we just turned on was Add Landscape, and this does like sort of it uses noise. We're going to talk about noise before the end of the day, to generate things that look like, in this case, mountains. But we can also do better. I'm going to point at this other one. Anybody familiar with GIS data other than Angela? So you at least heard of Google Earth, right? So the raw data, the numbers behind that, that's GIS data. And we have that available as a plugin. But kind of like me with making my plugins, it's somebody that has a full-time job, so they just kind of come here every once in a while. If you search for GIS Blender, or you see the name Blender GIS, there's this plugin ready to load in that actual real world data. So you just choose a spot on the map and you can pull it'll pull the landscape from that. It is just the raw numbers, so unlike Google Earth, we don't get the colors. We have to add in the colors with materials and shaders afterwards, but you can just grab any spot on the Earth because the entire Earth surface or almost the entire Earth surface is mapped out that way. You can see the little example in the video there. And for plugins like this that aren't quite ready yet, you just download it from GitHub here. I think is it downloaded? There you go. Yeah, so Blender GIS, and I think I need to extract the files.
The first one does also have a release, just gives you the zip file.
I need to unzip the folder. I'm used to doing that. But once you have it down on your computer, when you go to preferences where we're getting the extensions, or maybe it's just under add-ons. You can zoom back down my way. This little arrow here, you see that there's an option to install from disk. If you do that, you can just download and open up any plugin, because there's a lot that aren't actually already included in the repository. I think we just go to the folder. Nope. No such file or directory. Error message was about enter here. I just need to go to the I think I just go to this folder and hit install. Do from init. Okay, so yeah, I went right to the init.py file, the initialization, and that should have added it somewhere. I don't see it on the list. Didn't. Refresh. I must have skipped a step. Or let me try this. Maybe I do need the zip file. Zip folder and install that. Oh, no error messages that time. There we go. So then you can see it's enabled, and then that allows you to just grab any space from the data from Google Earth. You don't get the colors, so you have to add materials and stuff, but you'll have all of that data. Which can be really, really nice in a lot of games, not have to go through that. So I just wanted to show that plugin. It can be really, really useful to make a landscape, or if you're making a game that takes place in the real world, just grab the map of the real world. For us, I'm just going to go to the landscape button. So if we add a mesh, and under add mesh bottom, you should see landscape once that's activated. And these are parameterized things. So you want to expand that little box in the lower left corner, because here's all of our parameters. Change how tall things are, the height it goes up to. They call it offset, maximum, minimum. You can try changing some of the different parameters, see what each one does. Get different things. Lower depth, so we're gonna just less detail. So as we increase that, we get more and more detail. The offset X and Y, kind of like choose a different place in the noise pattern. We have all of those options. We also have a lot of presets. I'm gonna go with the river. I'll click on a couple of them. So different things like gullies and cliff faces, and you can use several and tie them together, and then all you have to do is make the little spot in between them, which can be handled really, really well with the sculpting tools. Go in sculpting mode and use the things that are like chisels working with clay, and kind of randomly fill in spots between like a cliff and under around in flat stones. This one usually looks pretty good next with water on it, but river, that's what I was looking for. So I'm gonna go with this one. So a nice little river flowing through. It's really small right now, bless you. It's 2 meters by 2 meters. So we'll want to scale it up, and we can scale it up either place. First thing I always like to do is rename these. Call one of them ground and one of them water. That way we can tell what's what, and the name, when we import it over into the game engine, the names will come with it. Can add a material. I'll do a new material for the water. Oh, you mentioned. There we go, and for this, I'm just gonna kind of choose some blue color and switch up in the upper right hand corner, switch over to material view so we can see that. And another thing I'm gonna do, I want it to be right about that surface, right about that spot, but I'm gonna move it down, this one down just a little. So it's, when we get over to our game engine and put a shader, tell you why I did this. I'm going to put another plane right on top of that, and have that doing all the light stuff, so it looks like it's rippling, but leave it somewhat transparent. And then this will be a surface that the character kind of walks on. That's something I found very, very useful, is to do two planes. You have that surface, and then underneath you have the player walking, and you can just switch it to an animation shape or a swimming shape, but keep the original collision box and all that. And it makes it a lot easier to control the player in the water. So I'm just going to move it down just slightly, and then the other plane, we'll create a plane over in Godot to sit right on top of that that's kind of transparent, and then we have a surface to walk on, so we're not sinking all the way to the bottom. We can grab this and just put a green material on the ground. That works, maybe a little darker. Something like that. And that quick, we end up with this nice little landscape for our character to wander around in. Right now, it's still a 2 meter by 2 meter square, so can't do much with it. There's one other thing I want to do. So I'm going to look from the negative y axis side, so the side that the river is flowing down.
What did you scale this to? So it's 2
Oh, I haven't scaled it yet. I'll scale it in just a second. So when we create a tree here in a minute, we're going to cover this whole area with trees, but we assign it to a mesh. So if we said cover the ground, right now, it would start generating trees and also put trees down here at what should be the riverbed. So I'm going to split that up a little. I'm going look straight on from the Y direction. So we're like looking down the river, but you can click these little buttons to do it. And if you switch to wireframe mode, it'll select through things. So when we're looking at it, it's just the wire mesh. We can select, and it'll select things behind the ones that are closest to us. And all I'm going to do is just take and draw a box to kind of select a certain part of the ground, something like that. I just select everything. Oh, because I'm in object mode. Sorry. Switch to edit mode, and then we can select just the vertices that are like above the water level. And then when you hit Control P, oh, maybe it's not Control P. It's just P.
separate by selection. I guess.
That's what I was looking for.
Yeah, just click P and it does it.
Oh, is it just P?
Yeah.
Sorry. I'm so used to hitting one of the other ones. So when you hit P, separate by selection. So now that upper part of the ground is separate from our lower part of the ground. So when we go to put trees on stuff, we can just use those. We can use that part, and then we won't end up with trees in the middle of our river. I thought about went back and forth on whether to come back and do that later or do it now, but figure we'd go ahead and do it now, and that way this model's done. But we can always come back and keep editing things. Now we need to scale it up to a decent size. Right now it's 2 meters by 2 meters. I'll scale it up 200 in every direction. So that was the first ground that scaled up. The second ground, scale that up. 3 units in every direction. And then the same thing for the water. 200, 200, 200. So that gives us a nice big level for our character to wander around in and do stuff in. But those generative landscapes can be really, really useful to get someplace to work on that quick, as well as that Blender GIS plugin. So that'll work. Need to save it, but to save time from importing, I'm just gonna go create a new Godot project and then save it right in the project. Create a new. This is gonna be our example for shaders, so I'm just gonna call it shaders. There we go. I just needed to start the project to get the folders. So if we go and save this in that new project, I make a new folder, all models.
I don't know that scale stories is that's after the water. Even though I went into different ones.
I'm not sure. Make sure you're only one thing at a time is getting selected, is my first guess. And then after scaling it, we want to set this back to just reset the scale so that this is the new 100% size. So again, for that, just select it, and hit Control A and apply all transform data. It's like one of the other ones, apply those transforms, and then underground, select that, and apply all transforms. So it gives us a nice little landscape to work with. And then I saved it in the Godot project, so as soon as we come over here, it should import it. And here, this is the first time I've put a Blender file right in Godot, so I'm getting this message. It's like, need to make sure it knows where Blender's at. It should scan through your system and find Blender, but if it seems to be pointed at the wrong thing, just browse to wherever Blender's installed, or if you have more than one version or something. Let's go ahead and hit confirm that. If you went with the default installation of Blender, it probably doesn't even have to scan to find it, because that's always going to go to the same place. And then when we set our world, just drag it out here, and does it automatically created the scene? Whoops. Seems awful bright. Might have to darken up those colors or dim the light or something. Notice I gave it a 3D, no 3D for a root, and then here's all of those pieces together. So you probably we might need them. So right click on it, and a little past halfway down the menu, you'll see editable children. If you click that, it'll separate out the different pieces so we can deal with it. Those colors look really bright, so I guess as far as making environments, when we get into shaders and materials and stuff, what we're really doing is manipulating how the light bounces off of it. How does the light hit the surface and bounce off of it and give us something that we can perceive? So I'm going to add a new light to this. You can go up to that root node and search for light. Directional light is like the sun. We're just gonna say it's coming in at some angle, and it kind of covers our entire world at that same angle. Omni light, Well, spotlight's obvious. Spotlight's like a flashlight. It starts at one point and kind of spreads outward from there. Or spot, I was trying to describe it without saying the word spotlight, but I think everybody knows what a spotlight is. Gives us a cone of light that starts at a definite point, and then we control what the cone is. And an omni light is a source that just spreads outward. So maybe like a torch. Right there at the center of the torch is there's a fire, and then there's light just spreading out in a circle from that central spot. I'm going with the directional light, like the sun.
Are you telling Godot's break the things into three separate?
How to what?
Are you telling Godot to separate it?
Right click on it and go to editable children. About half, a little past halfway down. Let's see, let me zoom in on the light here. And like with our sun, it doesn't matter where it's at. See how right now it's just all pointing in one direction, so it covers the whole world evenly from that one direction. I'll spin it down a little. And then we have a lot of options here. So could kind of change the color, the tint of it. So maybe at sunset, add a little bit more pinkish, sunset or sunrise, or something bluish, change the tint, and that's gonna make it look quite a bit different. I guess that green, the colors that are kind of picked randomly look okay in that. And it doesn't matter where we put it. I usually drag it like way up above everything else, so I don't accidentally click on it, but anywhere it's at in the world, it's the light is always shining in that one direction. You can see some of the other energy, so make it lower or brighter, which obviously for like passage of time, that's something that's really easy to do in your code, right? If you want to simulate passage of time, really all you need to do is start spinning that around, and there's day and night cycle. Spin it around, you probably turn the energy up or down on it to match the day. I'll turn it down a little. Originally pointed. Volumetric fog is how much it affects the fog. Sure. We haven't really talked about that. I think somebody's having trouble with their internet. Keeps leaving. It keeps getting kicked off the meeting. That happens sometimes. We'll look at fog in a moment, but this is how much does it affect the fog. Different things. How scattered or spread out is the light? Is it everywhere? Also where our shadows are. You can turn on shadows, make things look a little bit better, because we don't have much going on in the world right now. Actually, if it was brighter, turn that up brighter, and then there you can see a little more contrast between the shadows. Or if I turn the red off, there's a little more contrast in the shadows. And it doesn't matter, again, it doesn't matter where this is at. What matters on it is which direction the light is coming at. I'm gonna go back to like sort of a sunrise sort of tint to it. And then we can do other stuff we can add with the materials, different normal surfaces to break them up and stuff. Can keep adding different things, but y'all can see kind of a lot of what's there. Bias is like bias on a camera. How much is the light impacting things? Remember we talked about the culling, where we don't see, usually it's back face culling. With our 3D models, we only see one side of the face. So if I was to flip this over entirely and look at the world from the other side, since those are all planes, we wouldn't see if back face coloring was on, we would be looking straight up at the sky from this point. Because the front faces were all going upward. We kind of go through theirs, try different things with with lighting, change different things, see what effects you get. And as you apply different properties from materials like we looked at the other day, that light, the changes in the light are going to have a big effect. So as you're going through trying random things, keep that in mind, make little changes to your material and then change the light and see what those two things do together, because really it's the interaction of them that we see. And just like layer mask, I think that was last week's reading, wasn't it? Layer mask and collision layers. Maybe it was a couple weeks ago. We have a similar layering system for our light, so we can set it so that some things aren't affected by the light, if we don't want them to be. It was kind of a start, and let's see. I need to put a camera in here. The camera. All right, so that we're kind of looking at our world. I'll go ahead and run this scene. Oh yeah, save it as world. So there were we setting things up even before we added the light. We could see the light, and there was the sky, but now our sky's gone, and notice our colors all look a little bit different with the sky not there. That one that we were seeing before was just for editing stuff. There's a little button you can add that sky in, but let's do some stuff with the sky. We're going to do some stuff with the sky, so let's make a new one. We'll go back up to the root and add in, and it's under world environment. I usually search for environment. If you search for world environment, this is kind of our skybox. And if you look at the inspector panel, you notice that right off the bat, there's three empty slots. So it's can take a little bit to set up the sky. Two of those we can bypass and avoid. That's how the camera attributes is how the light reaches the camera. The properties we have for that. Well, click on it, look at it. I wasn't gonna do anything with it, but the blur, the exposure, blur and exposure, the main two things we have on it. If you have a halfway decent camera on your lens where you're turning, anybody ever worked with a good camera where you have an actual proper lens and you turn the thing you turn, those two controls, we have those for our camera, basically. And the one we have to have is a new environment. So we'll create a new environment, which is completely blank at this point. There's different options. Could be just a custom color, right? Choose some bluish, sky blue color. But notice how that affected all of the other light. It's just like in the real world, the color of the sky, light is reflecting off that as well and scattering in different directions, so it's going to affect all the other colors. But we can do better than a custom, just a color there. The one sky here is a shader. Canvas is for loading pictures into. We kind of load pictures in and manipulate things.
So sort of like in games where the skybox has a flat image set in a super far away where it doesn't really matter if it's flat or 3D.
Yeah, it's yeah, these are basically our options for setting up different skyboxes. Or since it does show up in this class when selling resources, that is a popular resource to sell, is putting together a nice sky that people can use in their game.
Interesting, you can make it a camera feed.
There's a lot of options we can do with it. So if you choose sky, you'll see,
I guess if someone has a webcam, you could make it so that it uses the webcam, so the skybox, which are just, playing the game.
yeah. You'll notice down here, there's some other ones. So fog. Default is really, really thick. So one thing I always like to do is add some transparency to that. Notice how it's just RGB color. We don't have the transparency thing. So you might want to make it kind of a light color like fog and turn the energy down on it so that it's not so thick. Or look at the density is already 0.01. It only goes up from there. So want really, really small numbers to get fog on there. I'll reset those. Right below fog is volumetric fog. So it's fog, but we define it as a shape. So if we wanted just a little bit of fog hovering above the river, but not over the land, we'd set a volumetric fog and then set up that shape and then apply the fog inside of that. Those add a lot to the atmosphere of your game. But like always, my recommendation is when you're not as tight of time constraints as we are in this 1 to 350 class with a lot of stuff to cover, sit down and just click on things, make little adjustments, and see what you like for adjusting the fog. And as always, with everything else in the inspector panel, we can access it from our code the same way and kind of change, manipulate it, and make it more dynamic from our scripts. Usually just from the transform data or like we've seen before, the naming conventions. Take the light energy, that's how much it's scattering the light. And as we turn it way down, it's a very, very thin fog, the light passes right through it. But as the light energy goes up, it's like a thicker fog, and to the point where you're inside the cloud and visibility decreases. That's kind of a nice one to make dynamic in a game. It really adds a lot of atmosphere, especially in horror games. If anybody's interested in horror games, because then you can make the fog bit thicker and cut down visibility at more exciting parts of the game. But yeah, it's just a slider, so it's a number, just changing, get a reference to that in the script and change the number and dynamically adjust the density. And today we want to look at shaders. So let's start with the sky shader. So after creating a new environment, we'll expand the sky option, or set background to sky, and then a new option will show up for sky, and we can create a new sky. Then we have to click that, and it's asking about the sky material. So we can put in just a basic material or a new shader material is the one we want here. So create a new shader material, and then click on that to expand it. And down at the bottom center, you'll see the shader editor tab. And click on that. This is where we'll write the code for it. Oh, one more empty slot. So keep adding those and expanding it. We collapse all of them. Collapse that. So we create a new sky and then create a new sky material. When we click on that, it expands. And the shader option, and it says shader's empty. So we'll click on that, create a new shader. I'll just call it cloudy. You can see the extension there. But that gives us something that we can open down here in our editor. There's different types of shaders. Most often for your basic materials, you're going to be using a spatial shader, but there are also fog shaders and other ones. Godot uses what's called OpenGL, which has been pretty much the standard basis for creating shaders for several decades now. The big one, Unreal, goes a lot further, but their library started as extensions on the OpenGL shaders. All of the different shaders available in Unity started as extensions on the OpenGL library. So it's sort of the standard to look at. And you notice we have just that declaration of what type it is, and then we have one function, and you can tell it's curly braces and semicolons. It's in C++ really, but we won't get into any of the object-oriented stuff. We're just filling out this one abstract method, and all the rest of the object-oriented stuff for C++ in the background. So I guess we could say it's like typing in C. We just need to fill out what we're going to do, what parameters we might need, and what do we want to be dynamic about this. So I guess the first thing we need for a sky is probably a color for it, right? What's the background color of the sky going to be? Or colors. The original thought for today had the colors fading, so it's like dark on the horizon and then got lighter as you go up towards the center. But that added a few more lines, and I thought it might kind of run us out of time. So we'll just do a single color for it. So some keywords. An important one is uniform. I didn't choose this word, but what uniform does is, like in the scripts we've already done in Godot, we have that export annotation. And when we use that, things show up in the inspector panel. When we use uniform, that's going to show up in our inspector panel. So we want a uniform vector 3, because a color is a vector. We talked about that earlier. And we need 3 numbers that go together. Some sort of name for it. I'll call it sky color. I'll use underscore sky color. Oh, and then I'm going to put a colon, and I'm going to type source underscore color. That's just a notes it changed colors, so a pre-built thing. What that did, we'll go back to the world environment and expand our shader out. Notice now there's this thing called shader parameters. That wasn't here a moment ago. But we have sky underscore color. So over here we have sky color now showing up, and we can just choose a color from this. Some light blue background color. We can't see it yet, but that's what goes down in our function. All of the built-in parameters, I saw the other day when we looked at materials, there was that long list of things. The albedo, the metallic, the roughness, the anisotropic, all those different parameters. And the code here are the name that we saw there. So that's one place you can get the list of words you need in all capital letters. So like the color of this is going to be assigned that sky color. End of instruction. So is a language we need the semicolons. Oh, because when it goes in the sentence, every time I hit that, I'm going to say end of instruction, but technicality, the computer reads our code backwards from the way we type it. So a semicolon technically means next instruction, but it seems odd to say that at the end of the line. So with that technicality mentioned, if you're not used to typing in languages that use semicolons, I'd recommend just every time you get to the end of the line, actually say that. So sky color, end of instruction, don't get used to saying that every time. And you can see, it kind of changed the appearance of it, but as we choose, now we can choose different background colors. Choose a darker blue. I put in sunset colors, so I'll go with a real dark blue. So some of those, sunset or sunrise colors come through a little bit more. But that, at that point, we could have just, picked one color. We want to get something dynamic on here. So I'm going to create another color, uniform Vic3, and I'll call this cloud color. And again, it's going to be a source color picker. End of instruction. So we have this other one over here to choose a color for our clouds to be. And it's just slightly off-white. And we want to mix those together. But need to mix them together a little unevenly, if that makes sense. Right? We want some parts to be white, and some parts to be the cloud color, and some parts to be the sky color. We don't want to put like pouring two paints together and mixing them. Right? So for that, we'll use a normal map. So I'm going to create a new use uniform so it shows anything. And then the key type is a sampler 2D. And I'm just going to call this normal. So we want to put a noise texture in here. Let's talk briefly about what a noise texture is. Oh, since y'all are watching that, I could just switch it to this view. There we go. That way it's a little bit bigger on the screen. Quick screens in the room. So computers are pretty good at coming up with random numbers. They're not truly random, but those algorithms seem very complicated. And if we just fed in a bunch of numbers, and then plotted them, we might end up with some crazy looking graph that has all sorts of highs and lows. And it's just, things are waving all over the place, right? They have some high numbers, some low numbers, everything in between. There's no pattern to it, right? It's good for when we want to do random selections and stuff, but if we want something, if we want to generate something like clouds in the sky, we need a bit of a pattern, more of a pattern to it. So noise is algorithms we run random numbers through to kind of smooth them out. So one of the basic ones is going to be Berlin noise. I'm only going to talk about two of them up here, but most of them are similar to this. So Berlin noise was invented for the original Tron movie, one in the early 80s, not the really great one in the early 80s, not the way back 20 teens. But they were bringing in digital effects to Hollywood. So to smooth out this randomness, what this guy come up with was we take different samples and then average samples. So in our first pass, I'm going to take the starting point and just duplicate the starting point. So the first pass is just a straight line. One sample. And then the second pass, I'm going to take maybe two samples from here. So So again, the starting point is always gonna be one of them. And then the second sample, I'll just come right to the middle, look down here, and it looks like the middle is way below where this is. So from that starting point, maybe I spread this out a little more. It's gonna come way down and then come back up to the starting point at the end. So I always want to come back to that starting point at the end. So then the second sample is just this nice smooth line. And that pattern's going to continue. So 4 samples the next time. So right at the beginning, 1, 2, 3. Yeah, 1, 2, 3, 4, and then we'll repeat that starting point again. So here it looks like we're above the starting point. This one is way down low, down even more than that other one and the second pass. And I did offset it because if we did 4 evenly, we would just end up with this piece right over and over and over again, right? Because it's a computer, we're going to keep using powers of 2. So usually in our script, we'll offset it a little. That way it's not a perfect match. Then this one looks like we're way up top. Let me clear out some of those extra ones. And see how eventually, if we took enough samples, we'd end up with back with our random numbers. But we're getting something smoother, so then we can average these together. And, at the beginning and end is always in the middle, because we intentionally started with a piece in the middle. I'm running out of room up there, so I'll do it in red down below. So we started in the middle, and then at this point, it's down a little, and then up quite a bit. So those would average to just coming up just a little bit. Then the next point, it's going down. We'd average what it is here, right? This one's perfectly flat, which adding that, right, an average, we add things together and then divide, that flat is going to cancel out some of this decrease. So then we get a nice smooth downward spot to here. Then that quick sharp downward turn between there and there. But still there's a flat line that works into that average and smooths it out. Then everything's going up. This one quite a bit, this one just a little bit, and then the flat line canceling that out. And then back down like that. So when we take all those different samples and average them together, we end up with a nice smooth surface. See how this is, I guess we could think of that like hills, right? It looks like a more natural shape. That's per wind noise. So just randomness. It's really fun to make these things. If anybody's interested, I can share some code, what it looks like in code to take those samples. But we just keep going through a loop, choosing the spots, get a value, and then we average them together. And what I drew as high and low here would be a grayscale. So like down at the bottom is black and up at the top is bright white. And then everything in between is gray. So all of our stuff is changing the grayscale value is what's going on there. We'll quickly talk about our other main type of noise. The cellular structures is another view we might have. We'll be looking straight on. Think of like static on a screen. Old TV sets. I think we mostly only see it in movies now, when everything was cathode ray tubes, and when there was no signal coming in, it was just randomly spitting out electrons. So some pixels would be white and some would be black, and we'd get that white noise on the screen. And that's kind of like that original random line. So our other main type is Voronoi, which I'm going to write also Musgrave, with n equal 1. And I'll come back and talk about that second label in a moment. So for this, we think of a grid, lay things out in a grid. We have our screen, and I'll just do a 3 by 3. That's probably plenty enough to write on the board. So we set up a grid, and each one of those grids will pick a random point. Maybe like here, and down here. Here, put that one at the bottom, that one near the top. In this corner, something down here, maybe just a little off center. We'll just loop through there, right? If that's a 16 by, each grid 16 by 16, we just kind of loop through there, pick one random number in that 16 by 16 grid. Then we go to the next one, pick one random number. We hold to that one. And then we go through and map all of the pixels that are closest to this point, to each point. So it's going to kind of come right between those. We split up something like that. Split through there. Somewhere up here. And everything in this area is closest to this point. Everything in this area will be closest to this point. Looks like there's another one kind of splitting those in half. That. So I might not have split that up perfectly evenly, but see how it looks more maybe like skin cells under a microscope, a very natural division of that grid. So that's our main 2 categories, and there are lots of subcategories of them. Things like Berlin noise, where we take a bunch of samples, put like black at the bottom, white at the top to get grayscale values, and then a bunch of samples, and we average those together to smooth it out. Or we split it up into a grid and choose a point, and then Voronoi is the closest point, which that's the Musgrave here of n equals 1. Musgrave is like that, only we don't have to do the closest point. We could do the 17th closest point, or the 3rd closest point, which I'm not even going to try to draw on the board here, but an easy thing for the computer to calculate. And that gives us nice, natural looking things from random number generation, which lead back into very natural looking backgrounds or landscapes. Yeah, like that landscape we just put in, the bumps and hills on that are from noise generation. They are from Berlin noise for that, the bumps and hills on the ground. So we just generated a bunch of random numbers, smooth them out so that it looks natural, and it looks a lot more natural. Similar thing when we put clouds in the sky. Well, I was going to use Berlin noise for this. So let's look at how we do that. Any questions about noise? That kind of makes sense. And kind of a fun algorithm to write. I've got some on my page. We look at what the code looks like. They usually don't take very much code. It's one of those things that takes more to describe it than it takes to code it up. Oh, I'm going to sign in to GitHub. That's weird. So I probably have to answer the phone too. Oh, messages from some of y'all in class. I will check those messages at break. Sorry. I guess I didn't notice it in my pocket. I didn't notice the phone vibrating. Since this is a programming class, I figure y'all might be interested in how we code things like that. 3, 6, 7. So this particular one, most of them are from nonlinear dynamics. That's the branch of mathematics that Most people refer to as chaos. Oh, whoops, okay, I didn't go to the main folder, not the test folder. But I did include some of the basic ones, so like Berlin, this is what it looks like, so. There's all a bunch of setup stuff, constructor stuff, here's where we actually do it, so we have a nested loops, and we'll determine how many times to go through. That's gonna be like our, called them octaves when he originally created it, so I think I did that here as well. But we set up some values to work with and an accumulator. Oh yeah, so I did call it octaves. So we'll start at 0, and then however many octaves, that's each sample is another octave. And we just go through and grab a sample. You can see that I copied the original one here, or stuck a lot with the original one. So we have the pitch. How far over are we? A lot of different things. So we'll do this over and over again, right? So we have this loop that's going to take all the samples inside of a nested loop here. Then as we go through, basically we're finding the offset. How far away is it from the spot where we wanted to measure it? A little bit of control, but you see it's only a handful of lines. And then at the end, we take the noise that we've ended up with, all of these samples, and then divide them by those accumulated values, like how many it is, so just the average. Fancy words to say average, like what value did we get along the way, and then what's that going to be? And then that's like this first point. Then we go to the next point, the next point, and the next point, and have all of those averages, and then we put them together. So you can see it's not a whole lot in code. Voronoi is even easier to look at. So yeah, we have the grid, however big our grid is, and we just kind of go through and choose a random spot in each one of in each grid, and then we go through every single pixel on the screen and determine which one of those random spots it's closest to, and then put it in that group. So not very, you can see it's not very much code to put them together. Kind of fun. I think it's fun. I enjoyed making those things. But once we have that, then we have a natural random pattern. A random pattern with a very natural feel to it, so we can start doing things with it. So over here we added this spot for normal. So let's go choose a normal map. Click on there where it says empty. Down at the bottom is near the bottom is new noise texture 2D. So we choose a new noise texture, then expand that out. Down at the bottom of that section is the where we actually pick the noise. Choose a new fast noise here. And then when we expand it, we have our different options. So smooth simplex. Simplex, you can see there's stark contrast, but that kind of follows suit from Berlin, but it does it a little bit different. Come down to Berlin, you can see this. So it started as just like white noise on an old TV screen, all randomized white and black pixels. And we smoothed it out into something that looks a little natural. Just change the speed values. Adjust the frequency to get more or less. I'll go something like that. Maybe increase the speed a little. Nope, not increase the speed. I'll set them under fractal. It kind of changes how they are. So notice how if I switch to ridge, the lighter parts became more pronounced and the darker parts got more separation between them. Ping pong kind of has a smoothing effect on them. I can keep it at FBM. So that looks like a nice pattern that could represent a cloudy day, basically. So I want to use that pattern to lay the clouds on. And make a move, because I apparently didn't put movement in the example paper I had in front of me. What is this? Oh, this is the one with the two sky colors. I'll grab the other one out of my office. So now we can come back down here and set up a color that mixes those two things. So I'm gonna create a new vector 3 because it's gonna be a color. I'll call it clouds. And it's going to be a new mixture of texture. So I'll create a new texture that mixes that normal map with our sky chords, which all in all capital letters. So basically take that normal map and put it in the sky coordinates. But we just want the color from it. We don't want the whole picture. So if we do .rgb, then end of instruction, it gives us a color map from there. Which we can't really see yet. So I'm going to create another color. I don't know, I'll call it final color. And for this, I want to mix. Oh, sorry, I just realized I should have zoomed in. Can you see that better? All right. I want to mix a couple of colors. So I'm going to mix the sky color with the clouds. And then we need some sort of number in here. I'll put try like 0.3. End of instruction, and then the color of our sky will change to be that final color. See how that map kind of so you can split up those things. Got that scene, we'll address that in a second. It starts to look a little bit more like a color. So what it is, this number, well, let me go the other way. If I switch it to 0.7, notice how we're getting more of the clouds and less of the sky color. So 0.1, whoops. 0.1 is almost all the sky color, and we can just tell there's some wispy clouds up there hanging about that might form into actual clouds later. So it's 90% sky color, 10% clouds at this point. 4, so that's going to be 40% clouds, and the other 60% sky color. So that's kind of how those mix. We need a couple of these check boxes over here to deal with that seam there where it doesn't line up at the edge. In 3D space and seamless, and there's one other one. And uncheck the generate maps. So excuse me. Uncheck the one that says generate and then click 3D space and maps. And that gets rid of a seam. So then we have a nice unbroken sky in every direction. One problem with this one, if we can see it here. I can't really see it. Up at the top, they're all coming together. So if you put a camera that you had control over in that world and like pointed it straight up. Oh wait, we do have a camera, don't we? So if I took that camera and then pointed it straight up, see how they kind of, it kind of mixes and matches. There's a little, we need more code to do that. I wanted a slight a simple introductory example. So realistically, it's really hard for a character to look straight up, right? Unless they fell on their back or something. There's a limit to how far up we can take, how far up we can turn our head. So we could avoid having somebody look at that particular spot. And then just looking off in the distance, it gives a nice impression of clouds. And again, that's all in the inspector panel, so we can refer to that shader and adjust those values as needed. Use the word uniform to put them in the inspector panel, and then once they're in the inspector panel, we can refer to them from our other script. Gives us something cloud-like. At this point, we might want to, oh, I would like the zoom buttons, get those out of the way. At this point, you might want to, and grab that, go back into those colors and maybe choose a lighter blue or a whiter white once you see how they blend together, and find something that, find some good colors. I'm just gonna go with this for now. Where am I looking at? It's awful stationary though, right? So it'd be nice if this could move. I was wanting to make it move before the break, but we've been at this for like an hour and 15 minutes. So you want to take a 10-minute break, and then we'll make those clouds move. Does that sound good? And it's really, really easy. All the stuff's built in here, but it's probably going to be like 10 minutes, and then at that point we'll probably be pushing an hour and a half straight of sitting in chairs. And remember the spiel on Monday, the ergonomic stuff. Sitting in chairs at desks is very, very bad. So we want to get up and move around. That's the biggest thing with the break. So let's take a quick 10-minute break, and then we'll make those clouds move after the break. Stop screen share. And yeah, little things like shaders can really make our game environments seem to come to life. But I will see y'all in just a moment. Stop recording.